Our first guest is Peter Winkler, who is a world expert in discrete mathematics and combinatorics and a mathematics and computer science professor at Dartmouth College. His work has had substantial impact on the design of algorithms and theoretical computer science. He's also a celebrated collector of mathematical puzzles, having written 2 books on the subject, as well as a monthly column for the communications of the ACM. Now, since I've started off every unit with a mathematical magic trick, I thought Peter would be an excellent person to beguile us with a few fascinating tricks of his own.
I have a puzzle in my book about a spy who's trying to convey information to her control. But the only means she has for conveying information is that there is a 15-bit radio broadcast every morning. And she has the ability, if she wishes, to alter 1 bit of that broadcast. But she doesn't know in advance what the broadcast will be. And so this is a case where potentially there are 16 different things she can do. There are 15 bits she can alter, or she could choose not to alter any bit. Which means that in theory, perhaps she could convey as many as 4 bits of information this way. Well, surprisingly, she can actually do that.
All right, let's make sure that we understand the setup here. I'm going to do this as a magic trick. So I'm a spy, and I'm in enemy territory, and I've got a message, 0110, that I need to transmit to my boss. Now, that's going to be tricky to do because I don't want anybody to know that I'm a spy in enemy territory. Fortunately, there's a radio broadcast tower in enemy territory, and every day it sends out a 15-bit message. And there's an example of a 15-bit message. Now, I can use that message to communicate with my boss, but I can't just change it arbitrarily to something completely different, because then people will know that something weird has happened. But I can flip just 1 bit. So I can zap the message and change just 1 of the bits. And my boss then is going to hear that, and we'd like him to actually interpret that as the message that I wanted to send. So let's see if it worked.
Based on the 15-bit broadcast I'm hearing, and the protocol that my spy and I arranged in advance, I know the message he is sending to me is 0110. Nice work, Agent P.
Ta-da!
Here's what you can do. And the solution involves numbers, which come up in other problems as well. So a number is just a binary number. What makes it different from an ordinary number is that when you add 2 of them, you add without carry. So they're added like vectors in a vector space over Z2. And they're called numbers. They were called numbers by John Conway because, as you may know, they are useful in analyzing the game of NIM. So what we can do is we take these 15 bits and we number them from 1 to 15. But instead of thinking of those numbers as ordinary decimal numbers, we think of them as numbers. So each position has a non-zero number, starting with 001 for the first position, and ending with 1111 for the 15th position. What the spy wants to do is to convey some number of her choice to her control. So, for example, suppose she wants to convey the number 1100 to her control. And what she's going to do is she's going to simply tell her control, look at this radio broadcast after I've altered it, and add up the numbers of all the positions where you see a 1. Now, when the spy sees the radio broadcast, she looks at what the numbers currently add up to. Say the numbers currently add up to 1010. Then if she changed the 1010 bit, they would add up to 0000. So that's what she would do if she wanted to convey 0000. She actually wants to convey 1100. So she adds that to 1010. It gives her a number. She changes the value of the bit at that number, and it works.